Hi guys, so today we're going to be looking at 2.2 characteristics of quadratic functions. Right here, I want us to identify the axis of symmetry to a quadratic function. The axis of symmetry is a line that divides a parabola into mirror images. And you can also find the axis of symmetry by identifying the x value of the vertex. So what does this mean? If let's say that we have a parabola right over here. The axis of symmetry is the line that cuts our parabola in half. And what happens is whatever points are made on this side should be pretty much identical or like a reflection or mirror of the other side as well. And we can identify what our axis of symmetry is by looking at the x value of our vertex. So if you remember, for vertex, it was using h comma k. We would identify what our axis of symmetry is just by finding out what h is equal to. And I'll write that this is our axis of symmetry. Cool. Alright, let's try using the symmetry to graph out a quadratic function. Let's say you are asked here to graph f of x is equal to negative x plus 3 to the power 2 plus 4. We want to label the vertex and the axis of symmetry. So if I'm going to do that, starting with number 1, I'm going to identify the vertex. Identify my vertex. If you remember from the last section, we learned that the vertex form of a quadratic function is f of x equals to a parentheses x minus h to the power 2 plus k. And if I were to align that with my function that I have right now, which is negative 2 parentheses x plus 3 to the power 2 plus 4, we can find out that our h value and k value are provided to us. So my h, and this is always the important part, is whenever you find your h value, it's always the opposite of what's given. So if I have a positive 3 in my h value, it always switches to being a negative sign then. If it was a negative 1, then it would change to being positive. But since we have positive 3, then h is going to equal to negative 3. K just stays the same. You don't have to worry about switching the signs to that one. So k just equals to positive 4. So my vertex here is going to be negative 3, 4. Done. After I do that, it's much easier to find the axis of symmetry. So I'm going to identify my axis of symmetry. If I'm going to find my axis of symmetry, all I need to do is look at my x value. So if my vertex is negative 3, 4, then that means that my axis of symmetry is just going to be equal to negative 3. Done. Once I do that, and I find my vertex and I also find my axis of symmetry, I can start graphing out my function. So right here, let's graph it out. I have my line or my graph here. Let me move it to the side like this. I also have here my x-axis being shown. Then I just need 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 3, negative 2, negative 1, 1, 2, and 3. This is negative 1, 2, 3, 4, and 5. So let's start off by graphing out our vertex. Our vertex is negative 3 over 4, so I'm going to go all the way up to negative 3, 4. move to the left 3 points, and move up 4 points. And from here, I can start finding out what my points are. Now, because of the fact that we know that the axis of symmetry is -3, right? Then it makes it easier to find out what the 3 points are on our graph, or what the 5 points are on our graph, because of the fact that whatever points I make on this side, they have to reflect and be a mirror image of the other side as well. So I just need to figure out either the points on this side or the points on the right side. And I'll just choose to find out what these points are. So if I'm going to find out what those points are, I'm just going to see what point is next to -3. It's just -4. You always want to just go 1 point away from your axis of symmetry and 2 points away from your axis of symmetry and graph out those 2 points. It's just because there's the smallest points next to your graph and makes it easier to find. So the point that's left of the axis of symmetry is -4. And then I'm just plugging in -4 into my function. So I get -4 plus 3 to the power 2 plus 4. That equals to -2 comma -1 to the power 2 plus 4. And that just equals to +2. Cool. So right here, we get our new ordered pair, -4, going up to 2. So we know what that one is. So I'm going to plot that first. And again, whatever is on this side of the graph has to also reflect on the right side of the graph too, as a mirror image. So I do know that the point next to -3 is also going to have to be going all the way up to 2 as well. So that's a reflected image. Then I'm going to go 2 points away from -3, which is -5. So f of -5, that equals to 2 minus 5, or -5 plus 3 to the power 2 plus 4. That equals to -2, and this is -2 to the power 2 plus 4, which equals to -4. So right here, starting at -5, I'm moving all the way down to -4, which is right here. And again, if I have to plot a point that's going all the way down to -4, then the next point over here has to go all the way down to -4 as well. So automatically from just doing that, I can draw out my graph now for my parabola. Done. And that's how you use the vertex and axis of symmetry to identify and graph out your quadratic function. Let's try and graph out quadratic functions in standard form. So this one's going to be a little different. We aren't going to graph it, but I will show you how to identify your vertex and your axis of symmetry. The functions that we have been using are usually in the vertex form, but sometimes you will receive a standard form. Standard form is when you have the quadratic function in ax squared plus bx plus c format. And so because of the difference in the format, your axis of symmetry is going to be a little bit different to find. We are going to be using the formula x equaling to -b over 2a to find out what our axis of symmetry is. And so in these cases, it's always good to start off by finding your axis of symmetry first, then afterwards your vertex. So let's first start off by working on this problem where it says here that we have f of x is equal to 3x squared minus 6x plus 1. We're labeling the vertex and axis of symmetry. So to start off, I'm going to identify my axis of symmetry. If I'm going to find my axis of symmetry, I need to use the formula x equaling to -b over 2a. And so right here, if I were to use the standard form, ax squared plus bx plus c, my b value is equal to -6, and my a is equal to 3. All I need to do is just plug that into my formula here. So we get -6 over 2 times 3. And that just equals to 6 over 6, which just equals to +1. So my axis of symmetry is x is equal to 1. Cool. Once you find out what your axis of symmetry is, then you can find out what your vertex is. So vertex, if I'm looking for my vertex, I'm just going to get my function f of x equaling 3x squared minus 6x plus 1, and I'm just going to plug in my axis of symmetry into all of the x values. So right here, we get f of 1 is equal to 3, parentheses 1 to the power 2, minus 6 times 1 plus 1, and that just equals to -2. That tells me what my y value is. So I get 1 from my axis of symmetry, comma, -2 from my solution that I received from plugging in the 1. And that would be my vertex answer. Done. And then because of this, we can also identify as a characteristic finding our minimum or maximum values from the standard form as well. If we're trying to find out what my minimum value is or my maximum value is, all I need to do is look at my a value in the standard format here. If my a value is greater than 0, so if it's a positive number, we call it a minimum value because it's the smallest value that's shown on the parabola here. If I were to draw it out, let's say that my a is positive, then my parabola is going to also be a happy face. And so my vertex is where my minimum value is at, the smallest value on the parabola. Okay, if it's a maximum value, that just means that it has to be smaller than 0, which means that it has to be a negative value. If it's a negative value, that means that my parabola is going to be shifting downwards. So it'll be like a sad face. So right here, if I were to draw it out, we have our parabola. And it's also going to be the value that's like the highest on the graph. So right here would be my maximum value. It would be the top, like the highest point that's being shown on this image here. Okay. So let's say, for example, we're asked to find the minimum or maximum value of f of x equaling to 4x squared plus 16x minus 3. It also asks us to describe the domain and range of the function and where the function is increasing or decreasing. So right here, first step that I want to do is find out and determine, do we have a minimum value or do we have a maximum value? All I need to do is look at my a value. So if I have f of x is equal to 4x squared plus 16x minus 3, automatically from using the ax squared plus bx plus c format, since this is my a value and a is a positive number, that means that we have a minimum value. Which also means that my image is going to be a happy face, because whenever you have a positive a, that means you may draw like a happy face. If it was negative, you would draw like a sad face. Cool. Now that we have that done, the next step is to identify what our axis of symmetry is. So axis of symmetry is next. And we're going to do this so that we can draw our graph. So for our axis of symmetry, we have here x equaling to -b over 2a. My b value is positive 16, so we get here -16 over 2 times 4 from the 4 over here. and that equals to -2. Once I find out what my axis of symmetry is equal to, I could just plug it into the vertex so that we can find out what my vertex is. So for vertex, if we're going to find vertex here, plugging in -2 into the function, so we get f of -2 equals to 4 times -2 to the power 2 plus 16 times -2 minus 3. And that just equals to 16 minus 32 minus 3, which is -19. So my vertex here is -2, comma, -19. Cool. So if I were to draw this out, and it's just like a quick sketch so that I could describe my graph. Let's say we have our graph right here. And then we have our vertex, which is showing to be around somewhere -2 going all the way down to -19. Let's say that this is -2, -19 is all the way down here. Then our vertex would be right there. Since we do have a minimum value, we said that our graph is going to be a happy face. So I'm just going to move my graph up like this. And from here, we can identify also what our x-axis of symmetry is, which is x is equal to -2. So once we draw that out, then we can start describing the domain and range of the function. We can also identify if where it's increasing or decreasing. So for the domain is looking at all the points on the x-axis that are being used in this image. Since the image is continuously going to the left and it's continuously going to the right, and there's no like open spots, that means that all the points are being used, which means that our domain is all real numbers. As for our range, not all the points are being used for range. Range, it keeps on going higher and higher and higher, but it starts at -19, and that's where it starts to increase. So I want to write here that we're starting at -19, which means that we have y has to be a bigger number or equal to -19. And those are all the points that are being used on the y value. The next part after that is to identify and explain where the function is increasing or decreasing. Whenever I look at a graph, we always look like the graph is moving left to right. So if I'm looking left to right, I see that we are decreasing all the way to -19, and then we start to increase after -19. So that's what I want to write for my function. So the function decreases to the left of x equaling to -2. And that just means on the left side of x equaling to -2, our image is decreasing. Then it increases on the right side of x equaling to -2. So x and increases to the right of x equaling to -2. Done. And that's how you would describe the following graph. Now the last type of form that you would see for quadratic functions is the intercept form. For intercept form, we use the following function where you have f of x equals to a times x minus p, that's multiplying with x minus q. Normally, if you have like a ax squared plus bx plus c format, you can always factor it out. And after factoring out, you get this intercept form. The nice thing about intercept form is the fact that it does provide you with your x-intercepts automatically. So you don't have to look for too many points to graph out a perfect function. It already tells you what your x-intercepts are. It also tells you a new formula for finding the axis asymmetry. So let's say that we're asked here to graph out -2 times x plus 3 times x minus 1. We're asked to label the x-intercepts, vertex, and the axis asymmetry. First thing that I want to work on is to identify our x-intercept. That's because it's already provided to us in the function. If we have here f of x equaling to -2 times x plus 3 times x minus 1, underneath is where I want to write down my intercept form, which is f of x equals to a times x minus p times x minus q. If I find out what my p value is and my q value is, automatically I know what my x-intercepts are. So just like before, if you see that the number is inside of the parentheses, we still need to change it to the opposite values. So if I have p and it tells us here that it's equal to positive 3, I need to change it to being -3 instead. Same thing for q. Q, it says that it would be -1, gotta change it to +1 instead. And so that would tell us what our x-intercepts are, which are -3, 0, 1, 0. The y value is always going to be 0 because of the fact that you have x-intercepts that you're looking for. So it has to be a point on the x-axis. And if it's a point on the x-axis, your y has to always equal to 0. After finding that out, we just need to find out what our axis asymmetry is. Axis asymmetry is easy to find once you know what your x values are. Symmetry. Because of the fact that you just need to enter them into the p and q over 2 formula. So right here, my p is equal to -3, my q is equal to +1. Divided by 2, we get our answer, -1. So our axis of symmetry is x is equal to -1. Cool. Once you're done doing that, again, all you need to do is plug it in to the formula so that you can find out what your vertex is. So right here, f of -1 is equal to -2, and then this is multiplying with -1 plus 3 times -1 minus 1. That just equals to -2 times 2 times -2, which equals to +8. So our vertex is -1 from our x-axis of x-axis of symmetry, and our y value is going to end our vertex here. Cool. So hopefully this helped. Good luck.